Another important thing we need to discuss is the relationship between populations and samples. What is a population? Population is a set of all objects you are interested in. For example, if you want to invent a medicine that can cure a lung cancer, it means that the population are all people in this world that have a lung cancer. So it's a pretty huge amount of persons. Or if you want to analyze a lake and find out if it's contaminated or not, the population is every single drop of water in this lake. So usually population is huge. Sometimes population can be relatively small. For example, if we talk about all patients in a particular hospital, usually every patient has its own records in the hospital database. So it means that you can deal with records for all patients in ideal case, of course. So in this case, you can work with the population, but in most of the cases you can't. So you have to take a sample. So sample is just a small part of the population you are working with. The basic idea is you take a sample, you analyze it, and then you generalize the knowledge about your sample to the whole population. So you investigate the sample, you get some knowledge about the sample, and then you extend or extrapolate this knowledge to the whole population. In this case, first of all, you must take into account that sample is always an approximation of the population. It will never be the same as a population. But luckily, in most of the cases, if your sample is good enough and you use proper methods, you can do that. You can do this trick. For example, if every time you have a blood test, they take like several milliliters of your blood, but they can take something about what's going on in the whole body, even though you have like up to 5 liters of the blood in the body. Or, of course, it's not a very good example after the last election in the United States, but still it can work in many countries. It's exit polls. So where you meet people who have voted for a particular candidate, for example, in the presidential elections, then ask them anonymously whom they are voted for. You can ask like maybe 1, 2, 5% of the people, sometimes even less, and then you can use mathematical models to predict the results of the election. And most of the time, again, we will not discuss the last presidential elections in the United States. It will work pretty good. Okay. For example, in Denmark, we have about 6 million per people in the country. Let's say 4 million can vote. And you can ask like several thousands people in different cities. Of course, the sample should be good enough. We will discuss that. And then you can predict the results of the elections before the official announcement. Okay. How to take a sample so you can use it for getting knowledge about the whole population? Well, first of all, you have to use a proper sampling procedure. Sampling is a way to take a sample. The idea is following: this sample should be both random and representative. What it means? Well, let's start with representative sample. Representative means it represents the population. So it's big enough and it's good enough to represent the whole population. Let me show you a very simple example. Let's say this is the population. Let's say we take a sample, just 3 points. Let's say this one, and this one. Will the sample be representative? Apparently not, because if you look at the behavior, if you look at the relationship between your points, you will think that population looks like this, but it's not. So this sample is not representative. But if you take another sample, let's say 6 points, one is here, one is here, one is here, one is here, one here, and one here, then you can use the sample to get a pretty good knowledge about your population. Of course, again, it will be just approximation. It will not be perfect, but you will catch the basic sort of systematic things. You will see what's going on in your population. So in this case, the blue sample is representative sample and the red is not. The second thing is that the sample should be random. What it means? It means that if you think about the whole population, about objects in the whole population, every object should have the same chances to be taken to a sample. Of course, in reality, it's not possible, but you should be as close to this as possible, because otherwise you will get wrong results. Okay. Once again, let me show you what random sample or not random sample is. Let's say you have a lake, okay, and you want to analyze if this lake is contaminated. And you know that this lake is not homogeneous, so different parts of the lake have different water quality. But you are lazy, so you took all your samples, let's say 6 or 10 glasses of water from the same part of this lake. This sample is not random, because you miss a lot of areas in your lake. So this sample is good for this part of the lake, but not for the whole lake. So it's not a random sample. It's a biased sample. So you sort of favor some particular part to the others. I must say that random sample is not necessarily representative. You already have seen that before when we took 3 points on this curve, and it was not representative, even though we took them sort of randomly. Okay. Another example of random but not representative sample can be tossing a coin. For example, if you toss a coin 3 times or 5 times and you get all heads, it will not be representative, definitely. You will think that in the population tail never possible, but it does, right? Why samples should be random and representative? Well, why it should be random? Because most of the statistical methods, they are based on frequencies, so they are based on this assumption that all your objects were taken randomly. And also, if you have several samples, they sort of not influence each other. We will discuss this later. And representative, it's simple, because we are going to use our sample to say something about the whole population. So if sample is not representative, you simply cannot do that. And remember that random is not necessarily representative. Now let's talk about some terms we will use later on our calculations and statistics. When we talk about population, we use capital N to define the number of objects. Usually we don't know that. When we talk about sample, we use a small n to define number of objects. And in most of the cases, the small n is much, much smaller than the capital N. Then, if we calculate some parameters of the population, let's say we calculate average of, average chloride content in the whole river. That's a parameter in the population. But if you talk about sample, it's a characteristic of your sample or statistic. Well, later you will see it's not always true, because there are also non-parametric methods that are not based on these parameters. But most of the time we will deal with parametric methods that are based on the different parameters and statistics. So in most of the time that will be correct. Now we can define a sort of a procedure for most of the experiments. So first of all, you define your population, and the first step you need to do is a sampling. So that's the first step. You take your sample, and you should do it so your sample is random and representative. It's very important. Use a priori knowledge about your population to get a representative sampling. Use a sample that is big enough. We will discuss some of these issues in this course. Even though sampling is outside the scope of this course, we will discuss some things related to sampling later. The second step when you get a sample is to describe your sample using different statistics and plots. And that's what we are going to do in the block 1. And then finally, when we got this description, when we got the knowledge about your sample, you do the third step. It's called inference, when you extrapolate knowledge about your sample to the whole population. And that will be the main purpose of the block 2. Because we have these 2 steps, describing sample and then making inference, we can also divide all statistical methods into 2 groups: descriptive statistics and inferential statistics. Descriptive statistics are methods that allow you to collect, organize, summarize, and analyze, and get some knowledge about your data, about your sample. And then inferential statistics is a set of methods that generalize this knowledge to the whole population. So the first block will be devoted mostly to descriptive statistics, and the second block will be devoted mostly to inferential statistics.